33. Okay, so we're only going to be worried with dilations like you guys studied before. Dilations with respect to a fixed point, and we're going to call that the center of dilation. For our purposes, that center of dilation will be the origin. So center of dilation, that's where that fixed point, we're going to expand from that fixed point. And again, the idea of a dilation is what you guys did with your meme project, right? You're either enlarging it, and some of us shrank it. There was a few of us who had a bigger image, so we shrank it. So an enlargement is a dilation, and there's something called a scale factor of a dilation. And this is often, I think the most confusing thing about dilations is the scale factor aspect. Okay, so when you guys were doing your scale factor for, let's say, your meme project, or when we were comparing proportional sides, we would say that whatever side we mentioned first, if we said that we had a 1 to 2 scale factor when we were talking about proportional sides of polygons, what that is interpreted as is whatever the initial image was, a unit measure of 1 would then result in a final figure that is double that unit. So 1 to 2 meant you had an enlargement where you guys went bigger. And so you want to pay attention to whether or not the description is about just proportional figures as you're looking at it, with whether that ratio is just a comparison of sides, like we would have here, or if that is that scale factor is a description of a dilation. And if it's a description of a dilation, it'll mention that it's a dilation. And so what we would expect that ratio or that scale factor to be that K value, which I'll circle as K, they call it K, and that value, we can look at the value and automatically know if it's going to result in something that will end up being larger or smaller. So an enlargement would result if K had a certain value. Do you guys remember? And this is the part that I think is review for some of you guys. If K was a certain value, then we would expect that the dilation would be an enlargement. Does anyone remember from previous years what that K value had to be? Any ideas? Let me just make it easier. If it's an enlargement, for example, yes, those are correct. If I anticipate that it's going to be larger, for example, if I told you guys double the size or triple the size, double is times 2, triple is times 3. So you can think of it as the multiplier. So in this case, if K is greater than 1, so say if K is 2, I would expect the image to double. Recall that that's slightly different from the way that I'm expressing it as a proportional sides of, and it's all like interpretation, but this one is also doubling, right? 1 to 2, which we might view as 1/2. So you want to distinguish between how is the problem presented. Is it presented as a dilation, or are they talking about corresponding sides? And so just pay attention to that aspect of it. Look for keywords. So an enlargement would be greater than 1. A reduction is a dilation. If greater than 1 is an enlargement, what would result in a reduction? If the K value was, very good. Okay, so if the K value was less than 1, but also that it was greater than 0, right? Because we can't, it wouldn't make sense to multiply by a negative number. So in this case, K is some number between 0 and 1. So think of like if I asked you guys to take your meme and then cut it in half. The 1/2 is that multiplier. It's the value that we're multiplying by, and multiplying by half is going to result in a smaller figure. So down below here, you guys have the, on the graph, we will dilate triangle DOG, which is not described there as what the coordinates are. So let me mark off what the coordinates are for you guys. DOG by a scale factor of 3. Can you guys type into the chat, would that result in a reduction or an enlargement, or reduction or enlargement? So there's one test question. It gives you guys just the scale factor for the dilation, and it asks reduction or enlargement. So very good. So you would expect that the final image would be larger. The center of dilation is the origin. And let me shrink this so you guys can see it. Label the dilated figure triangle D prime, O prime, G prime. the dilator figure image should be 3 times as far from the center of the dilation as the pre-image. After you've drawn triangle D prime, O prime, and G prime, fill in the missing coordinates. So can I have you guys take a moment and just fill in the coordinates for what you see for D, O, and G, what the initial pre-image is. So fill in the coordinate points that you guys see that I marked off, D, O, and G. Okay, so algebraically speaking, sure, someone needs the top of the top for a moment. Algebraically speaking, after you guys have the coordinates of your original pre-image and you know what the scale factor of that dilation is, does anyone know algebraically what can you guys do without even having to plot those points? How would you guys come up with what D prime is, O prime, and G prime, given the original coordinates and the scale factor? Does anyone know? What do you guys do to come up with the new coordinate points? How do I get D prime, O prime, G prime? If you know that the scale factor is 3, good. And I think I mentioned the word multiplier, but if the scale factor is 3 and it's an enlargement, what we would do is just multiply each one of the values, x values, y value on your coordinates by 3. So go ahead and do that, and then go ahead and plot your points. So I'm going to give you guys about 2 minutes to do that. And then I'll point out some significant observations that I want you to make from it. Okay, so multiply all the numbers by 3. So first point I'll just mention so that we make sure we're on the right track is going to be 6, 18. Again, I multiply the x values by 3, the y values by 3. I think it would help if you guys had a ruler as well, just to make the lines nice and straight for this next part. But I wanted you guys to also notice the observation of connecting your center of dilation. So there's your center of dilation is the origin. Go ahead and draw the segment that connects that center of dilation to D. And then if you guys can use a ruler and extend that out to D prime as well. And if you guys do that with each one of the points, it's like a nice prism that, or pyramid that emerges from that, with the top being, of that pyramid being your center of dilation or the origin. So go ahead and do that. And I wanted to point out to you guys as some observations as you guys are doing it. So if you're looking at the slopes that connect the pre-image to the slopes that connect D prime, or how to get from point O to D, if I had you guys describe what that slope is. What is the slope from the origin to D? Go ahead and type it into the chat. What's the slope from getting from O to D? And can you guys follow that slope? If I continue with that pattern, which you guys are saying 6/2, if you guys do 6/2 or 3/1, do you notice that as you follow that pathway, you also get to D prime? Okay, so the slopes of the segments that connect the center of dilation to D and then to D prime are the same. Okay, and we can say that that's true also going in this direction. Okay, so if I went to this point here, I would rise to run 6, which is a third. And then if I follow that pattern all the way up, I would hit G prime. So just kind of keeping those in mind. Now, we're going to write down the observations that we have here. So that was one of them. Another thing is that, how would you guys describe the slope of this line, this segment here? What's the slope of this leg? What's the slope of DO? Okay, that's good for you guys to remember because I know that showed up on a previous test. When you have a vertical line, think of when you guys are skiing, a slope of 0 is when you have a horizontal line, right? There's a 0 grade on, say, the bunny slope is really hard to ski on, so that's 0. This is undefined. There's no mountain that's directly vertical like this that we're going to ski off of, so this is an undefined slope. Okay, and so the undefined slope that we have for DO is also true for D prime O prime. And so if that's undefined, what's the slope of OG and O prime G prime? Okay, 0. So therefore it is 0 for both of those lines. And then we see that the slope that connects D to G and D prime to G prime also happens to be the same thing. Okay, so our first observation is about the slopes. So slopes of some segments in pre-image are same as image. So same slope. We might have to show that that's true when we're looking at these dilations as similar figures. Okay, knowing that they're similar figures, there's two things that's true. Okay, and that's going to come up on your test, is that if two figures are similar, what has to be true, you guys? What's true about angles of similar figures? Okay, angles are congruent. Very good. And what's true about sides? What's true about sides? I noticed that on the quiz, I saw some of you guys put sides are congruent, sides are not congruent, sides are proportional to each other, right? That's why we set up those proportions when we're trying to figure out. So sides are in proportion. Okay, and so let's go ahead, and those are going to be those things that we're going to try to show are true when when they ask us, is there a way that you can explain why they're similar? We're going to think of how we can show that the sides are in proportion to each other, or show one of those reasons why we know, like the angles, two angles are congruent, or side angle side side similarity. So on the next page, there's a few questions like this on the test, where you guys have that you're given two images, and instead of labeling it vertices, they just call this whole figure A and this whole figure B. And they're saying, determine whether the dilation from A to B is an enlargement or a reduction. So it's saying from A to B, so your pre-image is A, your final image is B. Can you guys describe to me what it is, and then what you think the scale factor is for that? Is it a reduction, or is it a enlargement? Okay, so we can see from A to B, it was enlarged. So we're going to say enlargement, and then they're going to ask you guys, well, what is the scale factor? I would encourage you guys to find the side that, and when I say scale factor and we're talking about dilations, if you guys can provide a numeric, like a number, okay, instead of like it being a ratio 1 to 2, we're going to express it as either a number between 0 and 1 or greater than 1. So in this case, find the side that is the easiest to find the lengths of, and that's going to be the base of these triangles. It went from a length of 3 to a length of 6. So you want to ask yourself, what are you multiplying by to get that? And that's going to be that, that K value that they're looking for, that scale factor. So K is 2. We went from 3 to 6. Okay, so can you guys go ahead and answer number 2 for me? And then we're going to go ahead, or actually, let's skip 2. Can you guys go ahead and do 3 for me? A is the original, B is the final. Okay, good, Christian. Okay, so let's talk about how we would come up with this scale factor. Okay, so I see that all of you guys have, it's a reduction. We say reduction when it's getting smaller. So that's great. And then we just find the length of one side. So the original image is 5, the final image is 4. So whatever you guys are multiplying by, it has to be a number between 0 and 1. That's one key, right? Because we're doing a reduction, so it has to be a fractional value between 0 and 1. And then you're asking yourself 5 times what is equal to 4. Okay, so 5 times what is equal to 4. Okay, so in this case, when you guys divide both sides by 5, you get that that factor is 4/5. And that makes sense, right? 5 times 4/5 is equal to 4. Okay, so you're going to come up with the scale factor by thinking whatever my original unit of measure is, I'm timesing it by that scale factor or that, that dilation factor to then get 4 as my answer. So that's one way to come up with it, especially those kind of pesky fractions. Your final question, or actually the final question when I'm looking at it in order, on your Unit 4 test is going to ask you guys to take a look at 2 images and describe what the dilation might be, or whether the dilation that is given results in similar figures. Okay, so in this, the figures have already been graphed for you. It just is, can we verify that that dilation, and I'll highlight that as an important part of understanding, can you verify that the dilation is a similarity transformation? Okay, and so we can do that a number of ways. If we are dealing with triangles, which is what you guys are having here, I want you guys to write down the three different ways that we can show 2 triangles are similar. Okay, so can you guys type into the chat, what are 3 different ways for us to show that triangles are similar? Triangles specifically. Okay, good. And as you guys are thinking about that, I'll give it another moment because Gavin was really quick with that. Go ahead and write those 3 reasons on top. Okay, perfect. And then, so AA, and this is for similar triangles, right? We're trying to show either AASAS or SSS. There was one question on the quiz that I saw a lot of us miss, and it gave you the dimensions of 2 triangles, and it had all of the sides of the triangles. Think back to the quiz, and if you guys remember this question. So 2 triangles were given, and you had all the dimensions of both images, the pre-image and then the final image. It wasn't a dilation, but you can think of it that way. So you have 2 figures and they were similar to each other. You just had to explain why. So the question was, were they similar? The answer was yes. And then why are they similar? And the reason was that if you matched up the smallest side of one triangle to the smallest side of the other, you could see that it created a proportion or a scale factor, and that scale factor is maintained for all three sets of sides. So it was through side, side, side that we could show that the triangles are similar. Here, the nice thing is that you guys have a right triangle here. So we know all right angles are congruent. I believe so, Gavin. So in this case, we already know angle A is congruent to angle D. Both are right angles. Okay, so that satisfies for me when I look up above, I know for sure that one of the angles, so it could be angle or side. Okay, so we then go back and we don't have any other information on angle C, B, D, or F. So maybe we can use sides. And so when I'm thinking about the lengths of sides, the easiest things to find lengths of sides for are segments that are vertical or segments that are horizontal. If they're not horizontal or vertical, what do you guys have to use if they're not horizontal or vertical? Like say you had to figure out the length of CB or EF. What is it that you guys are using to come up with those lengths? AB and EF. Yeah, so either thinking of it as distance formula or thinking of it as Pythagorean theorem, you can find the lengths, but it's not as easy to do. Whereas vertical and horizontal, we can just count the number of points, right? So go ahead and tell me, like, if I'm trying to match up, and let's see if I have this correct. I want to make sure, and this is what I'm going to ask you guys to be careful of, because on the quiz, I think maybe some of us rushed and maybe we matched AC. We thought that that was corresponding to DE. You want to look at like, okay, well, this side is the longer leg of this triangle. And so what should AC match up with on the other figure? What segment should AC match up with? DF. So maybe establishing the scale factor as AC to DF and showing that that is that the other corresponding side, the AB, must match up with the DE, and that ratio that you guys have will show that it's in proportion. So go ahead and figure out what those lengths are and verify that they have the same scale factor. Okay, so go ahead and do that. And that is a half. E is at a half. And type into the chat, what's that ratio that you guys came up with? And if you guys were to write, so very good, 2 is correct. If you do 8 to 4 is equal to 5 to 2.5, that's equal to 2. If you guys were to reverse that and you had initially on your work put DF over AC and then DE over AB, like basically the reciprocal of that proportion I set up, and you said that that it was 1 to 2, 1 to 2, that's fine too. You're just explaining that the sides are proportional. So I would say since the lengths of the sides are proportional, or you guys can just write the proportion, since AC to DF is equal to AB to DE, and angle A is congruent to angle D, then triangle ABC is similar to triangle DEF by what, you guys? By what one of those three above does this satisfy? Okay, sides are proportional, angle included in between are congruent, so by side angle side. Okay, so showing that the sides are proportional through finding the length of it, and then coming up with a conclusion from that. Okay, to make the next part faster a little bit because it does get to be a point where we have to do one calculation for multiple sides. What I'm going to have us do is whatever group you guys are in. So let's say you're in group 1. We're going to first look over the problem, see what we have to do for it. But let me shrink this in case some of you guys are still writing. So you guys have 2 triangles. This time the triangles aren't right triangles. So we have no information on angles. And so what that tells me to do is, okay, well, if I have no information on angles, the best way to approach this problem is trying to show that all 3 sets of sides are proportional. So what we would have to do is find all 3 sets of sides. And, you know, the question comes back to, could I have done that for this one as well? Sure, I could have done the distance formula on A, B, and EF and showed that it had the same proportion and make the same conclusion, but using side, side, side. Here, since I'm not given any information on any of the angle measures, I'm going to find the length of all the sides. So just so you guys know, and I'll talk about one with Pythagorean theorem, but I'm going to have you guys, or sorry, not Pythagorean theorem, but distance formula. If I can have you guys, you have the coordinate points above as well if you need to verify what the points are. If you're in group 1, can you guys find the length of GH? Okay. If you're in group 2, find the length of HG. And go ahead and type it into the chat and type the segment GH equals blank, HG equals blank. And then I'll talk to you guys and just make sure we go over one of the distance formulas. So we have 6 groups. Go ahead and work on either 1, 2, 3, 4, 5, or 6 based on your group. And then also tell me what it was that you found. So LM equals blank. And you guys, if you have a fractional value, like there is one with a fractional value, you guys can use a calculator to determine that. Oh yeah, let me show you guys the coordinate points. Thank you. The L and the N's are at a half a unit, 1.5. Yes, Colin, that's fine. Oh, Cody, you had the easy one, huh? So you guys can spot on the ones that when you're looking at a triangle, anything that's horizontal or vertical, you just have to count spaces. But if you had anything that wasn't horizontal, you had to use either the idea of and then also type out, Christian, can you type out what you calculated, like which segment you calculated? If you don't have anything that is horizontal, and so I'll pick the one that has a fractional value to it so that you guys can see the calculation behind it. And then I'll start to write in some of the measurements that people have calculated. And if you guys can just glance at the answer that they provided, those are the ones coming through so far, and double check that that makes sense to you. Yeah, sometimes we're off with our counting too. And again, if you are already done with yours, just look at the ones that have already been done and just make sure it makes sense to you. I'm just writing it out as I'm getting them on the chat. Actually, those were the ones that were the easiest to calculate. You can also use coordinate points, but I'm going to show you guys just a different way of thinking of finding it using distance formula or using something called Pythagorean theorem, which is where we came up with some of the measures for, or the formula for distance formula comes from Pythagorean theorem. So if you guys can take a look at LM, which is one that has fractional values, I'm going to zoom in a little bit here. Does everyone see that for every triangle that you guys have, you can break it apart into a right triangle, which then allows you guys to find the change of x and change of y just a little bit easier. And that change of x is going to represent for you guys one of the unit measure for the legs of that right triangle. So here we have that this length is 2, and that this change right here, this is a half unit, is 1.5. So if I'm trying to figure out what this the length of LM is, I can just see that this is 2, this is 1.5, and use Pythagorean theorem to come up with what LM is equal to. So if you guys can all write that out here, highlight LM and then, or that triangle that you guys see there, and do that. It's the square root of 2 squared, which is one of like a squared plus b squared is what I'm writing in there. 2 squared plus 1.5 squared. Okay, use your calculator. You guys should have the square root of 6.25, which reduces to 2.5. And that same measurement can be applied to mn on the other side. And you guys can see, again, it's the same triangle on the other side. So if you had like thought of it as a right triangle, this is the right triangle. Okay. Okay, so that just all establishes that you guys have the lengths. Once you have the lengths, I would just make sure to match up the corresponding sides. So for example, if I look at HG, that matches up with LM. And I just want to make sure and establish that all of the ratios are the same. So I'm going to say, okay, what is HG equal to compared to LM? And then HJ matches up with MN. And lastly, the base of both triangles. And sorry, I'm going from big to small, so I need to mention GJ before I mention LN. Okay, at that point, if you guys can all start to plug the numbers in and tell me what is the ratio that you guys get after you simplify that. Okay, perfect, you guys. We plug all of the hard work that we calculated, we plugged it back in, and we can say since that extended proportion is true, since you guys have that all the sides are proportional to each other, you guys can say that in words as well, or write it as an expression like that. Since all the sides are in proportion, triangle GHJ is similar to triangle LMN. And then what would you guys say as the justification? By what reason? Okay, perfect. Side, side, side. Okay, so in anticipation